What we tried to do, if you remember, Simon, is to keep all components on this side of the board.
Yes.
It's very tempting to actually connect some of the components underneath the board because you can come directly.
Perhaps you could put your finger in there and just point out.
If I actually move the board, it's very tempting just to bring some of the components to the back of the board and connect direct to the transistor pins.
Yeah.
Which would make it much simpler to put together. But what we tried to do is to keep everything on top of the board so that should we decide to change any or pick up any contacts or test points anywhere, it can all be done from one surface.
Now, I'll tell you what we'll do. I'll point out a couple of components that I know. I know, for example, that that large yellow object is a capacitor.
That's right, yeah.
And these two, that and that, are transistors.
The big black square plastic things are the transistors.
Yeah.
They're power transistors. Behind that you've got two neons which act purely to soak up any charging current should the connection fail between the circuit board and the battery. Behind that you've got two large power diodes which are directing the current, the charging current, into basically a bus bar that we've connected there, which goes underneath the board and comes back up just there.
So where's the bus board?
The little buzz bar we've connected for the charge runs from the diodes along the bottom of the board and back up to this lead, which is one of the charging leads.
The buzz bar is just like a connecting wire.
It's just a thick bar that you can actually run connections from should you wish to, which is similar to the connection we've done there, which connects the two emitters on the, I believe it's the emitters, on the transistors.
Just remind you, on the instructions that we got with the kits, it showed you the entire circuit, which seemed to be assembled on the back of the transistor, didn't it?
That's right, it all seemed to be mounted on the back of these transistors,
yes,
and all compacted into the plastic case that was provided. But I think, in my opinion, that would have made it impossible to have taken serious test points or voltage checks at various points, or even interchange components should we need to, because with the kit we've been supplied with several sets of resistors, obviously so we can interchange the resistors and get different values and different readings. In order to change those you need to be able to get at the things quite easily, and these two resistors which we bonked in there,
can you remember which resistors?
They were the highest value, they were the 470s.
With the kits we've got two lower ones as well,
that's right, and we decided actually there are three set of resistors with the kit. We decided to go for the highest ones to ensure that when we fired it up for the first time it had got maximum protection, so we're reducing the current through the circuit. Another important part of this circuit, which is different to the SSG1 circuit, is this triac. There's a triac with a diode bridging across.
Now, a diode makes current go in one direction.
That's right.
What does a triac do?
The triac is basically a cross between a transistor and a latching circuit. It's acting in this particular application, I think, as a safety valve, so that if any negative EMF tries to counter any positive EMF that is charging the battery, I believe that is A, stopping it going back through to the circuit, and B, it's acting as a transistor to switch the current, the positive current in the right direction right at the split second it's required. The little diode I put in there is just purely for us to be sure that we know that we've got current going into the circuit.
Point that out again,
that little diode there. It's just a light basically. If anybody does decide to build one of these and put one of these into the circuit, it has to be in line with a resistor, otherwise we'll just blow the thing. And the little resistor is there. It's just a 220 ohm resistor that I decided to put into the circuit, and it works fine.
So what's your conception of how the Bedini circuitry works, Tom?
That's a good question, Simon. A very good question. I believe that what we're doing is we're powering up the the motor with a primary charge, the magnets that because we've done some rewiring on the coils in there, we're only using 2 of the coils to drive the fan as opposed to all 4. The other 2 are actually being used to generate the charge by means of the magnets passing over the coils and creating EMF as the coil starts to collapse. And it's the EMF which is actually used as a charging current to charge the batteries. And that's about as far as I go with the theory on that circuit, Simon.
Well, you've done very well. So it's taken, how long has it taken? About 7-8 hours to put together?
I honestly believe it took us about 7 hours of, probably 6 hours of assembly, and probably 1.5 to 2 hours of scratching our heads trying to figure out what to do next, because in my opinion the instructions were probably ample for a good electronics engineer that wants to build one of these, but very, very lacking for a couple of idiots like us.
I think you're too modest, Tom.
You call the blog site Energy from the Vacuum for Idiots, and I think it was absolutely spot on.